fabulous students. I hope you guys are having a great day today. So today we are going to go through the Chapter 1, Part 1 test review. I'm going to do all the problems in this video. Feel free to skip ahead to whatever problem though you need help with. So starting with question 1, it says find the slope between the points 1, 3 and -9, 2. Before we go through this problem, let's remember slope and what the formula is. So slope, remember, is y2 minus y1 divided by x2 minus x1. These are both ordered pairs that you just plug in to find the slope. So this is the formula we're going to use. This does come from section 1.4 because that's where we learned about slope. So let's go ahead and plug these in. X1 and Y1 is what I'm going to label first. And it's just X and Y, which one comes first, which one comes second. Now that I've labeled them, I'm going to plug them into the slope formula. In the numerator, Y2 is 2 minus Y1 is 3. In the denominator, X2 is -9 minus X1 is 1. Now we're just going to simplify that on down. 2 minus 3 is -1, and -9 minus 1 is -10. And a negative divided by negative is a positive. So that slope is positive 1/10. The second question asks us to find the slope between the points 10, -2 and 19, -14. Again, our ordered pairs, we're going to label those x1, y1, and x2, y2. Now we can use those ordered pairs to go find the slope. Y2 is -14 minus -2. The denominator is x2 minus x1. Now we're just going to simplify. -14 minus -2, that double negative changes to a positive, which is -12. And 19 minus 10 is 9. Remember, it's a slope, so we're going to reduce our fraction by dividing the top and the bottom by 3, which makes -4/3. So that's a little bit of review for you over slope with the first two questions. Please remember your formula. Also, you'll need to be able to reduce your fraction. On questions 3 through 4, it asks us to write the equation of the line in slope-intercept form. Slope-intercept form is the equation y equals mx plus b, where m is the slope and b is the y-intercept. That's why it's called slope-intercept form, because it uses slope and intercept. Question 3 states that the slope is 3, and it passes through the point 1, 6, with this being x and that being y, and slope is m. So to write this equation, I'm just going to plug in the slope, x, and y. Because I'm missing b, I'm going to go plug in what I do know to go find b. So let's go plug it in. Y equals mx plus b. I know y is 6. I know m is 3, because they told us the slope. And we know x is 1. But I don't know b, so I'm just going to leave that the way it is. Now we're going to solve. 3 times 1 is 3. To get b by itself, I'm going to subtract 3 to both sides, so that 3 equals b. Now that I found b, I know my y-intercept and I know my slope. So I can write the equation. Y equals the slope, we were told, is 3. And then the b we just solved for is 3 as well. So that's the equation of that line in slope-intercept form. We used the slope and the ordered pair we were given to find the value of b. On question 4, we're doing the same thing, finding the equation of the line in slope-intercept form, but this time we're given two ordered pairs, 17,9 and 42, -6. To write an equation in slope-intercept form, you must know the slope and the y-intercept. On this equation, we don't know the slope or the y-intercept, but using our previous formula, we can go find the slope using the slope formula. So let's go find the slope. y2 is -6 minus y1 over x2 minus x1. Now we're just going to simplify. -6 minus 9 is -15, and 42 minus 17 is 25. Since it is a slope, we are going to reduce the fraction by dividing by 5, which makes -3/5. So this is the slope, which gives us m for our equation. But we still need to go find b, right? You need to know m and b. We found m, now we need to go find the y-intercept using the slope and one of the ordered pairs they gave to us. I'm going to use this ordered pair. Y is 9, m is -3/5, and 17 is x. Now you're just going to do the math here. -3/5 times 17/1 is -51/5 plus b, because you just multiply the fraction straight across. -3 times 17 and 5 times 1. To get b by itself, I'm going to add 51/5 to both sides of the equal sign, so that b is by itself. 9 plus 51/5, we do need a common denominator here. So to rewrite this fraction, I'm going to change this 9/1 by multiplying the top and bottom by 5. Now that these have a common denominator, we can add the fractions together. 45 plus 51 is 96/5. And that's the value of b. Since we know b and we know m, we can write our equation. M is -3/5 x, and b was the positive 96/5 that we found earlier. That's the equation of that line in slope-intercept form. Slope-intercept form was from section 1.4 as well. On questions 5 through 6, it asks us to write the equation of the line in point slope form. Now, point slope form looked a little bit different. It was y minus y1 equals m. In parentheses is x minus x1. Okay, so that is what point slope form looks like. On question 5, we know that the slope is 2, and the ordered pair the line is passing through is 3, 4. So the great thing is, point slope form, all you need to write it is a point and a slope. The slope is 2, which is m, and here's x, and there's y. So I'm just going to rewrite this out in point slope form. Y minus y1 is 4. M is 2, because that's the slope. And then x1 is 3, because that's the x value from the ordered pair. And that is now written in point slope form. On question 6, it asks us to write the equation of the line in point slope form, but this time we have two ordered pairs, 5, -1, and 10, -3. To write the equation in point slope form, you must have a point and a slope. Well, we're given 2 points, so we got the point part covered, but now we need to go find the slope. We can do that using our slope formula. x1, y1, x2, y2. Now we're just going to plug that into that slope formula. -3 minus -1 divided by 10 minus 5. In the numerator, -3 minus -1 is -2, because two negatives change that to a plus. And 10 minus 5 is 5. So there's our slope, which is m. Now we've got the pieces, we can go write our point slope form equation. Y minus y1 is -1 equals m times x minus x1. So there's one way you could write that equation, and these two negatives make a positive. Using that first ordered pair, 5, -1, that's how you could write point slope form. Or, because you have another point, 10, -3, we can write the point slope form using that one instead. Y minus -3 equals m, in parentheses, x minus x1. And these two negatives, again, make that a +3. So you can really choose which ordered pair you want to use because we're given 2. You can choose which one you want to use to write the equation in point slope form. Point slope form also comes from section 1.4, where we talked about linear equations. Questions 7 through 8 ask us to write the equation of a line satisfying the given condition. On question 7, it says that the line passes through the point -6, -4, and is parallel to the line defined by y equals -1/6x plus 2. When your directions say to write the equation of a line, the equation of a line is y equals mx plus b. So that's the form that we're going to write our answer in. To write that equation, though, you must know the slope and the y-intercept. As you look at question 7, we know that the line we're creating is parallel to this line, which means that the slope must be the same as it is right here. In order for two lines to be parallel, they must have the same slope. So the slope of our line is m equals -1/6. We also have an ordered pair that we can use to go find b. So let's go plug this in. Y equals mx plus b. I know y is -4. M we know is -1/6. And x we know is -6. Now we're going to go solve for b. -1/6 times 6 is +1 plus b. Subtract 1 to both sides. So -5 equals b. Now I know b and I know m. We can use that to write our equation. -1/6x minus 5. That's the equation of a line parallel to the line that's given to us. How we know that they are parallel is that their slopes are the same. On question 8, it asks us to write the equation of a line, y equals mx plus b. M is the slope, b is the y-intercept, passing through the point 2, -3, and perpendicular to the line defined by y equals 2/5 x plus 2. To write the equation of a line, you must know the slope and the y-intercept. So let's talk about the slope right quick. Two lines are perpendicular if their slopes are opposite and flipped. So the slope of our new line is going to be the opposite of 2/5, which is negative, and flipped, which is 5/2. So I flipped the fraction and changed it to the opposite sign. There's our new slope. Now I'm going to use the ordered pair I was given with the slope to go find the equation, just like we did on the last problem. Y is -3, m is -5/2, x is 2. Now I plug all that in to solve for b. -3 equals -5/2 times 2. The 2's cross simplify, so we're just left with -5 plus b. Then add 5 to both sides. -3 plus 5 is 2. So b equals 2. Now you've got your two pieces. You've got the slope and the y-intercept. -5/2 x plus 2. And that's the equation of that line perpendicular to the one given to us. If you struggled on questions 7 and 8, those came from section 1.5a, where we learned about parallel and perpendicular lines. Questions 9 through 11 ask us to find the x and y intercepts of each of those functions. So before we start going through and finding the x and y intercepts, there was a rule that we wrote down in our notes that told us how to do this. To find the x-intercept, we're going to plug in 0 for f of x, or whatever your function may be, and solve. To find the y-intercept, we're going to plug in 0 for x and solve. So that's how we find intercepts. Remember, these are also ordered pairs, x, comma, y. All right, so let's go ahead and do number 9. It says f of x equals the square root of x minus 2. First, let's go look for the x-intercept. To find the x-intercept, I'm going to plug in 0 for f of x and solve. So I'm going to plug in 0 for f of x and solve that equation. Solve it by add 2 to both sides. 0 and 2 is 2. To undo something that's square rooted, I'm going to square both sides of the equal sign. 2 squared is 4, and the square root of x squared is simply x. So x equals 4. That means that 4 is the x value, and 0 was the y value. So that's how you find the x-intercept. Now on the flip side, let's go get the y-intercept. To find the y-intercept, I'm going to plug in 0 for x and solve. So f of x, plug in 0 for x, and solve. The square root of 0 is 0, and 0 minus 2 is -2. So the y-intercept, 0, was what I plugged in for x, and what I got out was -2. And that's the y-intercept of that equation. we're doing the same thing, finding x and y intercepts of the equation 3x minus 12. First, let's go get the x-intercept by doing what our rule says. Plug in 0 for the function. So I plugged in 0 for g of x in this case. Now I'm going to solve for x. Add 12 to both sides. So 12 equals 3x. And divide both sides by 3. So 4 equals x. That means that 4 is the x value and 0 is the y value, because that's what I used for g of x. So that's the x-intercept. Now to go get the y-intercept, I'm going to plug in 0 for x. So I put in 0 for the x right there. And then solve that equation. 3 times 0 is 0. And 0 minus 12 is negative 12. So for our y-intercept, 0 was what I plugged in for x. And when I solved, we got negative 12 for the y. So that's how you find the x and y intercept for that equation. On question 11, it states for us to find the intercepts of m of x is x squared minus 6. To find the x-intercept, I'm going to plug in 0 for the f of x, or the m of x in this case, and solve for x. First, we're going to add 6 to both sides. So 6 equals x squared. To undo something that's squared, I'm going to take the square root, which gets x by itself, and the root of 6 are on the other side. Because though we took a square root, remember you always have a positive and a negative when you take the square root. So this x-intercept is plus or minus 6, comma 0. Make sure to write that as an ordered pair. All right, now let's go get the y-intercept. The y-intercept is found by plugging 0 in for the x and solving. 0 squared is still 0. Minus 6 is negative 6. So the y-intercept, 0, was what I plugged in for the x, and negative 6 is what we got when we solved. So that's a little review for you over how to find x and y intercepts. This came from section 1.3a, by the way, if you needed help reviewing x and y intercepts. On questions 12 through 14, it states find the domain and range of the function. This comes from section 1.3b. Domain is x and range is y. When we list domain and range, domain is x, so that means that we're looking left to right. And range is y, which means we're looking bottom to top, because it corresponds to the y-axis. So on question 12, there's a picture of a graph there, and this graph does go on continuously, which means you needed arrows at the end there. The domain is how far left and how far right the graph goes. As you can see, the graph does have arrows on either end, the left and right side, which means it does go forever to the left and forever to the right, which means it goes from negative infinity to positive infinity, because it's got arrows on the left and right side. Now to find the range, we're going to look all the way down to all the way up the graph. The bottom part of the graph has an arrow, which means it goes forever downwards to negative infinity. And it goes up to the top at positive 1. And I'm going to use a bracket there to close off the 1 because it does stop at 1. So that's how you find domain and range of that function. On question 10, We have another function that has arrows on the left and right side. Since the graph goes forever to the left and forever to the right, because of the arrows, goes from negative infinity to positive infinity for the domain. To find the range, we're going to look from bottom to top. So the bottom part of this graph is right here at positive 3. That's where it starts, that's where it's included, so I'm going to use a bracket. And the top part of the graph actually just keeps going on, up, and up forever because of the arrows to positive infinity. All right, next one's 14, the square root of x minus 4 plus 2. The domain, we're going to look from left to right. This graph has a leftmost point at 4, and I'm going to use a bracket because it's included. It's a part of the function at 4, and it goes off to the right forever, which means it goes to positive infinity because it's going to the right, which are positive x values. The range, we're going to look from bottom to top. The bottom part of this graph is at 2, and I'm going to use a bracket there because it's an actual point on the graph at 2. And how far high it goes up, it just keeps increasing, going upwards. So it goes to positive infinity with a parenthesis there because infinities always use parentheses. So that's a little review for you over domain and range of functions. Question 15 states, determine if the given graphs represent functions. To determine if a graph is a function, we used what was known as the vertical line test. And that just told us whether any x is repeated or not. This is from section 1.3a, by the way. So in question 15, as you draw vertical lines through the graph, it's crossing once each time, which means yes, it passes the vertical line test, which I'll abbreviate VLT. So it is a function. Going across 16, if I draw vertical lines through that graph, even though it is curvy, it only passes once each time, which means that no x's repeat. So yes, it is a function because it passes the vertical line test. And the last question on 17, if I draw vertical lines through the graph, it's passing only once each time through the graph, which means yes, this is a function because it passes the vertical line test. So the vertical line test is what we learned in chapter 1, just to kind of tell us if something was a function or not. Questions 18 through 21 state, evaluate the given functions below using g of x. And this is the g of x equation that we're using. This comes from section 1.3a also. Whenever you see the word evaluate, all that means is substitute in. So on question 18, I'm going to take 2 and substitute that in everywhere that I see an x in my function. So in place of x, I'm going to put 2 and simplify that on down. 2 times 2 is 4, plus 1 is 5. So g of 2 is 5, simply by substituting in 2 for x. Same thing on 19. G of negative 3 means take negative 3 and substitute it in for x. So in place of x, I'm going to put negative 3 and simplify that on down. 2 times negative 3 is negative 6, plus 1 is negative 5. So that one evaluates to negative 5. On question 20, it says g of a. So I'm going to substitute in a everywhere I see an x, which is simply 2a plus 1. You can't combine like terms there, so this one is done. 2a plus 1. Question 21 is g of 1/2. So I'm going to take 1/2 and substitute it in everywhere I see an x. 1/2 plus 1. Now we're going to simplify that. 1/2 of 2 is 1, and 1 plus 1 is 2. So that evaluates to simply 2. That's a little bit of review for you over evaluating functions. Remember, evaluate simply means substitute in. On the last part of your test review, questions 22 through 25 refer back to scatter plots and regression equations from section 1.5b. Question 22 states, draw a scatter plot for this data. And you guys have some space provided over here so you can draw your scatter plot. Before we start to draw it though, we're going to label what the axes are going to be. X always comes first, which is age, and life expectancy is the second column, which is Y. So along the bottom here, I'm going to label this age in years. So that's the x-axis. And then the y-axis is life expectancy, also in years. Now we need to decide what intervals we're going to use for the x-axis. The x values in the first column are multiples of 10, so I'm just going to count by 10. 10, 20, 30, 40, 50, 60, 70, and 80. The y-axis, I'm also going to count by 10s. 10, 20, 30, 40, 50, 60, and 70. The reason I chose 10 for the y-axis is because the data points in the y column look to be about 10 apart from each other. So that's why I chose to go by 10s on the y-axis. Alrighty, now we're just going to plot those points. So 10 years goes with 66 for the life expectancy. 20 goes to 56. 30 goes to 47. 40 goes to 37. 50 goes to 29. 60 goes to 20. 70 goes to 14. And 80 goes with 8. You don't have to be exact on your ordered pairs, it's just an approximation of where they would be on the scatter plot. So that's what our scatter plot looks like. Question 23 states, does there appear to be a linear correlation? Linear correlation means, does the graph, or the scatter plot, tend to make a line? So as you look at our scatter plot, there is kind of a line here going downwards. It's not a perfect line because it doesn't hit all the points, but the overall trend is downwards and all the points are tending to go down. So this is yes. On question 24, it says, using a graphing calculator, find the linear regression equation for the data to 3 decimal places. This is a quick review for you over how to find the linear regression equation in your calculator. First, clear out whatever's on the home screen there. Now we're going to enter our data from the table into the calculator by going to Stat, Edit, so click Enter when you get to Edit. And we want to clear out all of the data that's already in there. So I'm going to go up to L1 and click Clear to clear out my list. And then do the same thing with L2. Click Clear and clear that list out. In L1, I'm going to type in all of the data points in the first column. 10, enter. 20, enter. 30, enter. 40, enter. 50, enter. 60, enter. 70, enter. And 80, enter. All right, so there's L1. Now in L2, I'm going to type in the values in the second column of the table. 66, 56, 47, 37, 29, 20, 14, and 8. Now that we've got all those values listed, I'm going to go to second, quit to clear out that screen. Now we're going to go find our linear regression equation. Go back to your stat button, go over to calc, and down to lin reg ax plus b, and this is number 4. You'll click enter, go all the way down to where it says calculate, and click enter again. And that's your linear regression equation. Remember to round to 3 decimal places. Y equals negative 0.839 x plus, then b is right here, 72.393. That's how you find the linear regression equation for any data set. Looking back from your calculator to our test review, question 24 has an equation, y equals negative 0.839x plus 72.393. And again, that was straight from your calculator, rounding to 3 decimal places. On the last question, question 25, says using your regression equation that we just wrote down, can you estimate the life expectancy for someone who is 18 in 1989? And this hint is there, use 18 for x. So now I'm going to go plug in 18 in place of x, because that's the value they gave to us for x, and solve that for y. And you can type that into your calculator. When you do, you're going to get 57.291. And that is the life expectancy for someone who is 18 in 1989. Because this is a word problem, we're going to use a complete sentence to answer it. A person who was 18 in 1989 had a life expectancy of 57.291 years. That's the end of your test review.